let's learn about a difference of two squares. So this here is a difference of two squares. And you might say, why is this called a difference of two squares? Shouldn't a difference of two squares be a difference of two perfect squares maybe? This doesn't look anything like a difference of two perfect squares. Well, let's multiply this out using our double distribution. So this would be x times x minus y plus y times x minus y. So that would become x squared minus xy plus yx minus y squared. And this is an arrow, not a negative sign. So it would be x squared minus xy plus yx minus y squared. Now if you notice, this xy and yx are the exact same terms. They are like terms. So we could write this one as yx, or we could write this one as xy, because multiplication is commutative. You can multiply in either order and get the same answer. So since these are like terms, they cancel out, because this is plus 1 yx and this is minus 1 yx. So these cancel out. You can use a different color. So these cancel out. So you're left with x squared minus y squared. And if you look at the title of this video, it says difference of two squares. And this answer we have are two perfect squares, y squared and x squared, with a negative sign in the middle. So these are a difference of two perfect squares. So that's why this is the factored form of a difference of two squares. So if we look at this, we can see that we don't even have to do this double distribution, because we see a pattern. And the pattern is that if you have anything plus something else times that thing minus that thing. So if you have x plus y and then you multiply that by x minus y, then you get x squared plus minus y squared. You don't even have to do all this double distribution, because it'll waste a lot of time. All you have to do is you have to say, oh, this is a difference of two squares, because it's, let's say here, 5 plus 7 times 5 minus 7, x plus y times x minus y. In this case, x would be 5 and y would be 7. So you'd say, oh, this is a difference of two squares. So it would just be 5 squared minus 7 squared. So if you do that, 5 squared minus 7 squared. And we just simplify. 5 squared is 25 minus 49. As simple as that. That's it. So let's get into how to factor this back into its factored form. So step 1, we have to recognize that this is a difference of two squares. And a difference of two squares, have two terms. So this is a difference of two squares because it only has two terms. It's a binomial. And they are perfect squares. So both of the terms are perfect squares. And they are being subtracted because they are a difference of two squares. They are being subtracted, not a sum of two squares. If this was 25 plus 49, this would not be a difference of two squares, because it's not a difference. For it to be a difference of two squares, they have to be subtracted. And that is a common mistake, so don't do it. And the next step into factoring is we have to find the square root of the first term and then the square root of the second term. So we need to find square root of both the terms. So let's say we don't know what the factored form of 25 minus 49 is. Let's just take that for an example. So the first step into factoring is to see if it's a difference of two squares. And they have two terms, 25 and 49. They're both perfect squares because 25 is a perfect square root, which is 5, and 49 is a perfect square, which is 7. And they're being subtracted. So they're being subtracted. So this is a difference of two squares. Now we know this is a difference of two squares. And it is because we just multiplied it out. But let's pretend we didn't do that. Next, we have to find the square root of both of the terms. So the square root of 25 will be 5. And the square root of 49 will be 7. So we found the square root. The next step is to make a product of the sum of the roots times the difference of the roots. Okay, so we have 5 and we have 7, right? So first we have to make a product of the sum of the roots times the difference of the roots. So the sum will be 5 plus 7 times 5 minus 7. And we just factored it back into its factored form. We factored a difference of two squares. So first we have to recognize that it's a difference of two squares. Then we have to find the square root of the terms and then factor it. So let's try two examples right here. So the first step for this one is to see if it's a difference of two squares. So do they have two terms? Is it a binomial? Yes, it is, because we have two terms, 144 and negative x squared. Are they both perfect squares? 144 is a perfect square and x squared is a perfect square. Are they being subtracted? Yes, they are. They're not being added together. Next, we have to find the square root of both the terms because they're perfect squares, right? So what's the square root of 144? Well, square root of 144 is 12. And what's the square root of x squared? Square root of x squared is x because x times x is x squared. Finally, we have to make a product of the sum of the roots and the difference of the roots. So we would have 12 plus x times 12 minus x. And that's it. We just factored the difference of two squares. The difference of 144 minus x squared. So now let's do a slightly harder problem. So as you see here, we have two terms. And are they both perfect squares? Yes, they are, because x plus y whole squared is a perfect square because it's x plus y quantity times x plus y quantity. And is 4 a perfect square? Yes, it is. So the square root of this term would be 2 times x plus y, because if we used exponent rules and we bracketed this and squared it, we have a power of a product. We would apply the exponent to all the terms. So we would apply it to 2 to the power of 2, which is 4, and x plus y to the power of 2, which is x plus y squared. So 4 times the quantity x plus y squared is a perfect square. And just like that, this one is also a perfect square, because the term outside the parentheses is a perfect square, 81, the square root of 81 is 9. And x minus y whole squared is a perfect square because x minus y times x minus y is x minus y squared. So the square root of this would be 9 times x minus y. So finally, we have to make a product out of it. We have to factor it. So it will be 2 times x plus y plus 9 times x minus y, and then that whole thing times 2 times x plus y minus 9 times x minus y. Now we have to multiply it out. So let me go up here to multiply. So we would just distribute. So we have 2x plus 2y plus 9x minus 9y, and that whole thing times 2x plus 2y minus 9x plus 9y. So now that we've written this as a product, all we have to do is simplify. So all we have to do now is combine like terms inside the parentheses. So our final answer will be, so we would combine this 2x and this 9x. This is an x. This is also an x. So we would combine this 2x and this 9x to get 11x. And then this 2y and this negative 9y would be negative 7y times the quantity 2x and negative 9x make negative 7x plus 2y and 9y make 11y. So our final answer for the 4 times the quantity x plus y whole squared minus 81 times the quantity x minus y whole squared will be 11x minus 7y quantity times the quantity negative 7x plus 11y. So this is how you factor a difference of two squares. Thanks for watching.